Hi, my name is John Krochmally, and I've created these video modules for people needing to understand and apply their skills knowledge to install, service, and maintain technology controlled by automation systems, and particularly the Programmable Logic Controller. Programmable Logic Controllers, or PLCs, are frequently found in many applications involving automation and instrumentation. In this presentation, we will cover the typical digital input wiring associated with the common programmable logic controllers. We will also explore various troubleshooting techniques necessary to determine and correct problems related to digital field devices that are connected to various types of PLC assemblies. There will be 4 learning outcomes associated with this presentation. Number 1, identify PLC digital input terminals. Number 2, provide power wiring to the PLC digital input field devices. Number 3, measure power supplied to PLC digital input devices. And number 4, troubleshoot common PLC digital input problems. Such terms as digital, Boolean, discrete, and binary are used by different automation system manufacturers to identify technology having logic of only 2 states of condition. Devices such as switches and loads usually have only 2 conditions of operation. Switches are either opened or closed. Loads are either energized or not energized. These are examples of technology having only 2 states of condition. For this presentation, the term digital will refer to this type of logic application. Programmable logic controllers, or PLCs, come in a vast array of sizes and designs. The Allen Bradley Compact Logic, Micrologic, Control Logic, SLC500, and the Omron Mini PLC are usually rack-mounted and come in various combinations, consisting of input and output modules. The rack mounting usually involves DIN rails that allow these units to be easily placed into or taken out of circuits. The Compact Logics, Control Logics, and SLC500 PLC assemblies will have their digital input modules assigned in specific locations in their assembly array as shown. Micrologics and the Omron Mini PLC are considered to be brick controllers and will have their digital input terminals located at the module top location. In this presentation, we will use this graphic for orientation purposes, as well as to understand wiring concepts. Notice that the float switch, FS1, is a digital device. It has only 2 conditions, opened or closed. Let's consider first the PLC digital input terminations. Digital inputs are those whose logic consists of 2 and only 2 states of condition. As indicated in this graphic, switches identified as S0, PB1, PB2, and LS3 only have 2 positions. They are either opened or closed, depending upon sense condition. As the graphic shows, an applied power of 120 volts AC is available to digital field devices and identified at the top left of the graphic. Other specific PLC input modules can accept other applied voltages such as 24 volts AC, 24 volts DC, 12 volts DC, and others. Notice that when associated switches are in the closed condition, this same voltage then appears at the PLC input terminals. In this graphic, we see the input terminals located on the PLC digital input module section. These will receive the voltage coming from the source, whatever that source voltage is going to be. Notice that the terminals are numbered starting with 0 and increasing to 3. These terminal address numbers will be associated with the programmed instructions stored in the PLC's central processing unit. Notice also the use of a COM or common terminal that serves to complete the electrical circuit back to the voltage source. All PLC inputs will have associated LED lights that will respond to the voltage conditions at their related terminals. It is important to understand that the LED light associated with each terminal will only illuminate when voltage pressure is present on that terminal. This graphic represents a common method that PLC digital input modules are wired to field devices. PLC input field devices will communicate their condition to the PLC input module based upon the circuit shown. PLC digital input verification and troubleshooting begins with a multimeter configured to read voltage. In this graphic, it will be voltage AC. By applying our meter across the voltage source, we may measure the applied voltage of 120 volts AC. If during this test measurement we measure 0 volts, we can determine that the power is absent at this location and that there is a problem somewhere upstream from this location. With our voltmeter, we can measure the voltage appearing across the switches. With power sent to the switches, if the voltmeter measures 0 volts, the switch is in the closed position. If the voltmeter measures the applied voltage, in this case 120 volts, the switch is in the open position. We can also use our voltmeter to measure the voltage appearing on the PLC input terminals between the terminal numbers and the COM or common terminal. If the associated switches are in the closed position, the applied voltage will be measured. If the associated switches are open, the value of 0 will be measured. In this graphic, we see that switch S0 is closed, resulting in 120 volts appearing on terminal 0 and illuminating the LED 0 above it. With switch S0 closed and applying our voltmeter across input terminal 0 and COM, it allows us to read 120 volts on our meter display. Again, notice the illumined LED 0. Opening switch S0 drops the voltage away from the input terminal 0 and turns off the LED. The Omron Zen PLC digital input terminals are located at the unit's top section. The terminal marked NC is typically wired with a grounding neutral conductor, and that conductor will be white in color. The 120 volt power conductor is wired to terminal marked I1, and located directly upstream is the switch marked PB1. Our voltage configured multimeter can measure the applied voltage that operates the PLC by placing the meter leads across L1 and L2 to neutral. If applied voltage is present, 120 volts AC will be measured. As previously shown, we can measure voltages appearing on the input terminal marked I1 in reference to the NC terminal. If the upstream switch is in the open position, 0 volts AC is measured. If the upstream switch is in the closed position, 120 volts AC is measured at terminal I0 and reference to the NC terminal. Allen Bradley SLC 500 PLCs have specific modules for digital input devices. As shown on this graphic, if PB10 is in the open position, 0 volts AC will be measured between module terminal 10 and COM. As shown on this graphic, if PB10 is in the closed position, 120 volts AC will be measured between module terminal 10 and COM. Allen Bradley Micrologix 1000 is another brick-type controller whose digital input terminals are located at the unit's top position. Troubleshooting these controllers uses the same process.